This lesson is from Mrs. Cucci's College Now Pre-Calculus class. Today we're going to be talking about determinants and the Kramer rule with matrices. All right, so we do have two different objectives that we'd like to reach. We're not going to get them all done in one day. It will be a 2-day lesson, so there will be a second part to this video. So the first objective that we'll probably get through today is how we evaluate determinants of square matrices. We'll save Kramer's rule for tomorrow's lesson. All right, so determinants of square matrices, basically what a determinant is, it's a special number that helps us describe attributes of matrices. They also help us define the inverses of matrices. Okay. So with every square matrix, we can associate it with a number called its determinant. Okay. A determinant of a 2 by 2 matrix, so let's say the determinant of matrix ABCD, or ACBD, is denoted ABCD. So notice the notation, it goes from those matrices, the square brackets, to almost what looks like an absolute value. And the way we define that is that actually we have some math we do to figure out what the determinant is. And it's actually pretty simple. It's just A times D minus B times C. So it's very simple math. It's not hard to find. It's just a little bit different from what you're used to looking at. Okay. This is going to go away, so if you haven't gotten this down yet, make sure you do. All right, so example 1 says we're going to evaluate the determinant here. Okay. Whoops. So again, what we're doing is we're using that AD minus BC. So the math is not hard. Essentially, it's kind of like cross multiplying. So radical 2 times negative radical 2, and negative 4 times negative 3. Here we get negative 2, and over here we get positive 12. Put those together, and the determinant for this matrix is negative 14. So again, the math is not difficult. It's just a matter of remembering the process and how you go about it. All right, so evaluating determinants using cofactors, this is a little bit different. We are going to talk about something called a minor. So for a square matrix, we'll call it A, we're basically following through by deleting the ith row and the jth row of a column. And I know that doesn't make any sense now looking at it, but it will in a moment, so bear with me. All right, so for the matrix A, and it's A sub I, J. So notice that I and the J are two different things. It's not, when we put them together, it's going to look like two numbers together, but it's two separate numbers and not one number. So you'll see what I mean in just a moment. So first column, negative 8, 0, 6. Second column, 4, negative 6, 7. Third column, negative 1, negative 3, 5. That's our 3 by 3 matrix. Okay. So it wants us to find each of the following. It wants us to find the minor 1, 1 and the minor 2, 3. So again, that's not 11. It's actually 1, 1, I being 1 and J being 1. And minor 2, 3 is I being 2 and J being 3. So it's not 23. It's not 11. So kind of get that out of your head. That 1, 1 means first row, first column. That 2, 3 means second row, third column. That's what that means. Okay, it's your I component, J component. Okay, I'm going to have to move this again, so I apologize in advance. Okay, so let's start with A. And again, we want minor 1, 1. So we're going to put, go away, go away, go away. Put my matrix back. And what that 1, 1 means is basically you're going to take row 1, and you're going to take column 1, and you're going to get rid of them. Okay? And it's going to leave you with a matrix, or a minor 1, 1, with 6, 7, negative 3, 5. Okay. So now to find the determinant of that, because we're going back to a 2 by 2, you're following that same rule of AD minus BC. So we have negative 6 times 5 minus 7 times negative 3, which is negative 30 minus a negative 21, so plus 21 equals negative 9. Okay? So that number here is telling us what to get rid of in order to create my 2 by 2 matrix. All right, so now we're going to look for minor 2, 3. So same idea. Let me get rid of this and just kind of rewrite this, save myself some work here. Negative 8, 0, 6, and we had 4 and negative 1. So since I want 2, 3, I'm getting rid of the second row, third column, which is going to give me my new 2 by 2 of negative 8, 0, negative 1, negative 3. Okay, find the determinant, do that kind of cross multiplication piece. Negative 8 times negative 3 minus, I thought I was going to get through the whole thing without it doing that. I don't know why it does that. And negative 1 times 0, which is going to give us 24 plus 1, or, I'm sorry, just kidding, 24 plus 0, which is 24. All right, so as you can see, it's actually pretty simple. It's not earth-shattering stuff. It's just a little bit different from what you're used to seeing. Okay. Okay, so the next thing we're going to be talking about is cofactor. For square matrix A, the cofactor A sub ij of an entry A sub ij is given by, so it's a formula. Basically, we're going to be working with this formula in order to find cofactors, where M sub ij is the minor. So we just talked about how to determine that minor. So now we're going to be looking for cofactors. Okay. So for the matrix that we were given in example 2, we're going to use that in order to find these cofactors. Okay. So with A, we're going to start by taking the minor 11, which we know to be negative 9 because we just found it. Okay. So now we're going to use that information in our formula, and I can rewrite that formula so it's in front of us. Okay, so that's our formula. So now we're basically just plugging in here, okay? We know what I is, we know what J is. They're both 1. So we're going to have negative 1, and then 1 plus 1. And then since we know our minor 1, 1, we're going to be doing negative 9. Okay? So negative 1 squared gives me a positive 1, times negative 9 gives me negative 9. And that's it. It's as simple as that. Okay? But you have to have that minor in order to do it. And luckily we already found those, so it makes it a little bit easier. So our minor 2, 3 was 24 from up above. So negative 1 raised to the 2 plus 3 times 24. Negative 1 to the 5th power is negative 1 times 24, which is negative 24. And there we have it. So again, the math is really simple. It's just a matter of remembering what you need to do in order to find the cofactor. Okay? Okay, so determinant of any square matrix. For any square matrix A of the order n times n, where n is greater than 1, we define the determinant of A, denoted, and we talked about this a little bit earlier, it looks like at the absolute value, right? Choose any row or column multiply each element in that row or column by its cofactor and add the results. The determinant of a 1 by 1 matrix is simply the element of the matrix. The value of the determinant will be the same no matter which row or column is chosen. So we're going to go through to see how we actually do this. We'll take it slow, step by step, and this will be, we have one more example after this. Okay, so we are going to evaluate the determinant of A by expanding across the third row. So I'm giving you very specific examples here. Here's my matrix. It's a 3 by 3. Okay. And we want to expand across the third row. So when we do this, we're taking those third row values. Okay. This might be a little confusing at first, so watch carefully. You're going to take this value here, and then it's your cofactor 3, 1, third row, first column. Okay? Plus your second one here, -3, times your cofactor of third row, second column. Plus, you get the hint here, 5 times the cofactor of third row, third column. Okay, so you do have to know what those cofactors are, so we are going to have to go through that and do that. Okay. Okay, so we have -1. And there's your third row, first column, raised to the 3 plus 1. So this is our formula from the last one, right? Times, okay? And that's that we got by getting rid of that third row, or first row, third row, first column. Good Lord, okay. So our next piece, we're going to have -3 times, again, that -1 because that's coming from the formula, 3 plus 2 times, and in this case, since we're getting rid of third row, second column, my new determinant here. And last but not least, 5 times, and again, my formula, 3, 3, so that's what I'm getting rid of, which is going to give me -8, 0, 4, -6. Okay, so pause here, get it down, make sure you know where everything is coming from, okay? So if you see these values here, here, and here are coming from here, here, and here, okay? This piece is the equation for cofactors, right? And then this is your determinant. Okay, so pause this here and get it down. I am going to have to make this disappear, so make sure you have it all down. And again, that determinant is just that simple math, AD minus BC, right? So nothing earth-shattering here. It's just different from what you're used to doing. All right. So where we left off, right? So when we do this math out, we have -1 times -1 to the 4th power, so it's -1 times 1. And then the determinant, 0 times 7 minus -6 times 6, plus -3 times -1, -8 times 7 minus 4 times 6, plus 5 times 1 times -8 times -6 minus 4 times 0. All right, so we get -1 times 36 plus 3 times -80 plus 5 times 48. I'm not going over that math with you. That should be in your head by now. So -36 plus a negative 240 plus a positive 240, which is going to give us a negative 36. So that is how we find the determinant expanding across the third row. All right, the very last example we're going to do is actually going to be how you find this determinant in your calculator, because it can be done in your calculator. But remember, you still have to be able to do it out by hand as well. Okay. So the matrix that I want you to evaluate is going to be 1, 6, negative 1, negative 3, negative 5, 3, 0, 4, 2. And I'll show you how to do this in your calculator. So make sure you write that down, please. And then Kramer's rule will be for tomorrow. Okay. So in your calculator, what you're going to do is you're going to actually go to your book, and you want determinant. Now, determinant is this DET, okay? Determinant for square matrix, okay? Head on to bring it over to a calculator page, and then you're actually going to put in your 3 by 3 matrix. You can find your matrix template right in your template key. It's right here. And it's 3 rows, 3 columns, so that's good. And then you just put in those values. So 1, 6, negative 1, negative 3, 5, 3, and I'm going to backtrack. I'm sure somebody caught me and you're yelling at me at home. Negative 0, 4, 2. Hit enter, and what do you know? It's 26, and that is it. That's all she wrote. Okay. So please make sure you come prepared with any questions tomorrow, and we will finish the lesson in tomorrow's video. Thanks, guys.